Welcome to Homework Lib.
Hi, so for this problem we have a set of different solutions. For each of them, during the lab session, in theory you should have the values for pH that you measure using the pH probes. But without making use of that data, we can directly find out if the solution is going to be acid, basic, or neutral. So for each of these different solutions, what I'm going to do is look at the equation that gives the acid, basic, or neutral behavior for each of them. So in the case for NH4Cl, what is going to happen is that the NH4 plus ion can give an hydrogen to the water in order to generate the hydronium ion oops, plus NH3 in aqueous media. Thus, this solution it is going to be acidic. Next up, what we're going to have is the bicarbonate ion, HCO3 minus, can react with water in order to generate carbonic acid, that is a weak acid, plus OH minus, giving us a basic solution, as you can see from the pH measured in the lab. Next up, we're going to have the nitrate ion. We can get rid of the potassium over here, and we're just looking at the nitrate that is going to be involved. The reaction of nitrate with water would generate a strong acid, right? Let's say that assuming that this reaction goes forward, what would happen is that we would be generating nitric acid. So in this case, since the resulting product is a strong acid, then what we're going to get is that no reaction happens and this is going to be a neutral solution. And the same thing goes for the salt. If you look at the Cl minus ion, let's assume that it reacts with water and generates HCl. That is not going to be able to happen because HCl is a strong acid, it dissociates completely. So the solution is going to be neutral as well. For the next two cases, things changes a little bit. In the case for NaCN, the cyanide ion, Cn minus, can react with water, generating a weak acid, that is HCN plus OH minus. So the resulting solution it is going to be basic. And for the phosphate ion, what we're going to get is phosphate 3 minus can react with water in order to generate HPO4 2 minus plus OH minus. So this is going to give a basic solution. And actually, in the case for phosphate in here, we can have a lot of different reactions. Actually, we can proceed and add more hydrogens over here because all of them are going to be, all the resulting products on this side are going to be weak acids. And you can actually, if you want, write down all of the possible reactions that we're going to get in the equilibrium. All of these species are going to be present in solution with different abundances depending on the final pH. Sorry, this one is without a minus, plus OH minus. But the result it is going to be that we're going to have a basic solution. So what we can see from here is that if the reaction of one of the ions with water is going to generate a weak acid, then the solution is going to be basic. Such are the cases are this one, and all of this in the phosphate. If the reaction with water of one of the ions of the solution generates a weak base, for example, NH3, then this solution is going to be acidic. And if the ions come from the neutralization of a strong acid with a strong base, such as the case of HNO3, that is nitric acid, and of sodium chloride, then the solution is going to be neutral.